Hello students, today we will proceed further in the solution of definite integrals, and we will take up the next article, that is definite integral by substitution. So as discussed earlier in the previous video, in order to evaluate the definite integral, what we are required to do is we are required to first solve the corresponding indefinite integral without the limits. Then if it's a case of method of substitution, we solve the indefinite integral by substitution. And what are the steps involved in that? That we will first make a substitution, solve the integral in terms of the new variable. After getting the result, we again resubstitute the value of the new variable and get the result. And now after solving the indefinite integral, we will find the corresponding value of the definite integral by substituting the limits, upper limit of the original variable minus the lower limit of the original value variable, and get the result. However, while doing the definite integral, we can reduce the calculations to a great deal by ignoring the step 3. That is, now what is the step 3? That we resubstitute after solving the integral. After solving this the integral, we have to resubstitute the variable in terms of the original variable. Instead of doing that, what we do in case of definite integral, that after substituting, we change the limits also corresponding to the new substituted variable, and then we complete the solution in terms of the new variable only. Let's see how. Okay, so for that, let me take a simple question. Let's take an example which says that I is equal to minus 1 to 1 5x raised to power 4 square root of x raised to power 5 plus 1 dx. Very obviously it's a case of method of substitution, because there is a involvement of a function of a function, and we can easily see that the derivative of the internal function is present outside. So what we do is I'll first take up this question by the regular method and then take it by the shortcut method. Okay, so according to the regular method, what we have to do is we have to solve the indefinite integral first. So put x raised to power 5 plus 1 as t, which gives us 5x raised to power 4 dx as dt, and so integral of 5x raised to power 4 square root of x raised to power 5 plus 1 dx becomes, this gets absorbed in dt, and so we get t raised to power 1 by 2 dt, which gives us t raised to power 3 by 2 upon 3 by 2 plus a constant. Of course, constant here we don't write because we are dealing with ultimately with the definite integral, and this is equal to 2 by 3, 3 raised to power 3 by 2. And so in terms of the original value, we get variable, we get 2 by 3, and in place of t we write x raised to power 5 plus 1 whole raised to power of 3 by 2. Therefore the given integral becomes 2 by 3 x raised to power 5 plus 1 whole raised to power 3 by 2, and in between the limits minus 1 to 1. When we substitute the values, we get I is equal to 2 by 3, and this becomes 1 raised to power 5 plus 1 whole raised to power 3 by 2 minus 2 by 3 is common to both the terms, so we'll let the 2 by 3 remain outside, minus you substitute x equal to minus 1 in the function, we get minus 1 raised to power 5 plus 1 raised to the power of 3 by 2, which on solving gives us 2 by 3, 1 plus 1 is 2, 2 raised to power of 3 by 2 minus 1 raised to power 5 would be minus 1, so it is minus 1 plus 1 which gets cancelled, and this gives us 2 upon 3 into 2 raised to power 3 by 2. So if you want, you can also write it as 2 upon 3, and this is 2 raised to power 3 by 2, which is 8 square root of 8, that is 2 by 3 square root of 8, which is into 2 root 2, and ultimately you get this is equal to 4 root 2 by 3. Okay, now let's see by the shortcut method or the direct method what we get, or we also called as the shortcut method. So initial step is the same, that is we are starting with I is equal to minus 1 to 1 5 x raised to power 4 square root of x raised to power 5 plus 1 dx. We start with the same, that is put x raised to power 5 plus 1 as t, we get 5x raised to power 4 into dx as dt. Till here it's the same. Now here at this stage what we do is we change the limits. So when x equal to minus 1, t is equal to 0, substituting over here, and when x equal to 1, t is equal to 1 raised to power 5, which is 1 plus 1, that is 2. And so the new integral becomes, we get it as, we write the function in terms of t, that is t raised to power half dt, because this portion has got absorbed in dt. Till here it's okay. Now the new integral limits would be in terms of t. So here it is t equal to 0 to 2. Here it was x equal to this. Okay, so here this becomes t, and simply we evaluate the question as if it was the question given to us in terms of t. So what we get is t raised to power 3 by 2 directly 0 to 2, which gives us 2 raised to power 3 by 2 minus 0, which is equal, and this when you integrate it, you have to also have the denominator 3 by 2. So this 2 by 3 is as it is, raised to the power of 3 by 2 minus 0, and so I comes out to be 2 by 3, and into 2 raised to power 3 by 2 is 2 root 2, which gives us I is equal to 4 root 2 by 3, which is the same answer as this. And as you can clearly see that the question which took so many steps to solve by the regular method, in the direct method we could simply skip out 2-3 steps from the original method and still get the same result. So from now onwards we will be evaluating definite integral using the direct or the shortcut method only. So let's start with question exercise 7.10. So exercise 7.10, and let's take up a question number 2. It gives us 0 to pi by 2 square root of sine phi cos raised to the power of 5 times phi d phi. So very obviously inner function needs to be substituted in terms of t. That is the regular thing. So you put sine phi as t, you get cos phi d phi as dt. Now when phi is equal to 0, t is equal to sine 0, which is 0. Now when phi equal to pi by 2, t is equal to sine pi by 2, which is 1. So the new limits are t equal to 0 to t equal to 1. Now let's write the function. So it becomes, I'm writing it originally in terms of phi only because I need to simplify this cos raised to power 5 so into a form where we can substitute t. So how we write it as square root of sine phi, and this can be written as cos raised to power 4 phi into cos phi d phi, and this can be written as 0 to pi by 2. Now square root of sine phi, and this is cos squared phi whole squared. So 1 minus sine squared phi whole squared into cos phi d phi. At this stage, when you substitute sine phi as t, cos phi d phi gets absorbed in dt, and so we get I is equal to, this is t raised by half 1 minus t squared whole squared, cos phi d phi becomes dt. Now the limits will be written in terms of t. So when phi is 0, t is 0. When phi is pi by 2, t is 1. So we write over here 1. Now simply evaluate like a regular integral, 0 to 1. T, this is what, 1 minus t squared whole squared. So it can be written as 1 minus 2t squared plus t raised by 4 into dt, and we evaluate it as t raised by half minus 2t raised power of 3 by 2. No, half into t raised by half into t raised by 2. So that is 4 plus 1, 5 by 2 plus t raised power of half plus 4 is 9 by 2 into dt. Now evaluate, and this is from 0 to 1. We get t raised by 3 by 2 into 2 by 3 minus 2 t raised by 5 by 2 plus 1 is 2 plus, so 7 by 2 into 2 by 7 plus 9 by 2 plus 1 is 11 by 2 into 2 by 11, and this is from t equal to 0 to 1. The answer comes out to be 2 by 3 into 1 minus, this is 4 by 7 into 1 plus 2 by 11 into 1 minus, this is when we substitute the upper limit, minus when you put t equal to 0, all of this becomes 0, and you can just simplify it as 2 by 3 minus 4 by 7 plus 2 by 11, which can be easily solved. Okay, so the same way we get the another question. So let's take up question number 4. Now in question number 4 we get I is equal to 0 to 2 x square root of x plus 2 dx. Now as usual, as the previous question, we put x plus 2 as t, we get dx as dt. Now when x equal to 0, t equal to 0 plus 2, which is 2. When x equal to 2, t is equal to 2 plus 2, which is 4. So we get t becomes from 0 to 2 to 4, and so we get I is equal to, t is from 2 to 4. In place of this x, we can write t minus 2. In place of this x plus 2, we have t raised to the power half is already there. Dx is dt. So simply it gets evaluated to 2 to 4, t raised power of 3 by 2 minus 2 into t raised power of half into dt. Evaluate it like a previous question. We get t raised power of 5 by 2 into 2 by 5 minus 2 into t raised power of 3 by 2 upon 3 by 2 is 2 by 3, and 2 to 4. I becomes equal to 2 by 5 into 4 raised power 5 by 2 minus 4 by 3 into 4 raised power of 3 by 2. This is the original function, minus we have to substitute t equal to 2. So 2 by 5 into 2 raised power 5 by 2 minus 4 by 3 into 2 raised power of 3 by 2, which can be easily solved, and you can get the answer. I is equal to 2 by 5. Square root of 4 is 2. So into 2 raised power 5 minus 4 by 3 into square root of 4 is 2. So 2 cube minus. Now this becomes 2 by 5. 2 raised power of you can write 2 raised power 4 is 2 raised power of 4 by 2 into 2 raised power half, and here you get 2 raised power of 2 by 2 into 2 raised power half, which can be easily simplified. 2 by 5, this is 32, minus 4 by 3 into 8, minus this becomes 2 by 5 into 2 squared, that is 4 into root 2, minus of minus is plus, 4 by 3 into 2 into root 2, and then you just put them together and write the answer. So what we get is 64 minus this is 32 upon, oh sorry, this is 5 and the denominator are different, so simply write 64 upon 5 minus 32 upon 3, and this is minus 8 root 2 upon 5 plus 8 root 2 over 3, and this can be just either you can write the same denominators together or simply leave it, and so you get the answer as 1 upon 5 times, and you can write 64 minus 8 root 2 minus 1 upon 3 times 32 minus 8 root 2, and this is the answer. Okay. Now same way, now I'm going to take up two you can do the rest of the questions also, but I'll take up two extremely important questions, question number 8 and question number 9. So let me first take question number 9, which is similar to what we have taken already, and this gives you 1 by 3. This is extremely important question. 1 by 3 to 1 are the limits, and the function is x minus x cube raised power of 1 by 3 dx upon x raised power 4. Now as we have done, it is a question which is similar to the case of 1 upon x, and then we had x raised power n plus 1 square root or some power, and we had dealt with it by taking this x raised by n outside. So same way we do the question here. So what we do is, since there is a presence of cube root here, we take out this x cube outside. So what we get is 1 by 3 to 1, and we take out x cube outside, so it is this into x upon x cube minus 1, and then we solve it like a regular question. So what we get is I is equal to 1 by 3 to 1, and this becomes x. This is 1 upon x squared minus 1 whole raised power of 1 by 3 whole upon x raised power 4 into dx. And then we deal with it like a regular question. I is equal to 1x gets cancelled, you're left with cube. Now this is 1 by 3 to 1, 1 upon x squared minus 1 raised power 1 by 3 whole upon x cube into dx. Very obviously, if you put this as t, 1 upon x cube into dx gets absorbed in dt, and then we use the regular method of solving it. So put 1 over x squared minus 1 as t, we get minus 2 over x cube dx as dt. Now again, since it's a definite integral, we have to substitute back in terms of, substitute the or find the limits also in terms of t. So when x is equal to 1 by 3, we get t is equal to 1 upon 1 by 9 minus 1, that is 9 minus 1, which is 8. So the lower limit is 8. The next one is when x is equal to 1, we get t is equal to 1 upon 1 minus 1, which is 1 minus 1, which is 0. And so the integral becomes from 8 to 0. This is t raised power of 1 by 3, and this x cube dx gets absorbed in this x cube ds gets absorbed in dt, and we get here this is dt upon minus 2. So minus 1 upon 2 comes outside. And now what we get is, simply evaluate I is equal to t raised power of 1 by 3 plus 1 upon 1 by 3 plus 1, minus half is as it is, and the limits are from 8 to 0, and this becomes minus half. This becomes t raised power 4 by 3 and upon 4 by 3, so 3 by 4, and this is 8 to 0. And now we apply the limits and get I is equal to minus 1 by 2, and this is 3 by 4, and this is 0 raised power 4 by 3 minus 3 by 4, and this is 8 raised power of 4 by 3. Solving it, minus 1 by 2, this is anything into 0 is 0, minus 3 by 4. 8 raised power 4 by 3, first we find cube root of 8, that is 2, so 2 raised power of 4, and I becomes equal to minus half into this is this vanishes, minus of 3 by 4 into 16. Minus of minus gets cancelled, this goes 4 times, this goes 2 times, and so ultimately we get 3 into 2, which is 6, and 6 is the answer. Now we take up another very important question, that is question number 8. Now question number 8 says I is equal to 1 to 2 1 upon x minus 1 upon 2x squared whole into e raised power 2x dx. So if we observe carefully, it seems to be of the category e raised power of x into fx plus f dash x. Let's see whether it is so or not. So if you just see, yes, there is we know that the derivative of 1 upon x will involve minus 1 upon x squared, but here there is a 2 extra. More so, we have a 2 in the coefficient of e raised power of x, coefficient of x in the term in the exponential term. So before trying to apply that result which we used in integration by parts, we have to first substitute 2x by t, and then maybe it will fall into place. So we put 2x as t. This is another very important question. Now you put 2x as t, we get 2 dx as dt. Now again, since it's a case of definite integral, we will find the new limits. So changing the limits, we get when x equal to 1, t is equal to 2, and x equal to 2, we have t is equal to 2 into 2, which is 4. So the new limits are from 2 to 4. Now I becomes equal to from 2 to 4. Now clearly this 2 to 4 are limits for t. In place of x, we will write 1 upon t by 2 minus, again in place of x we write t upon 2 whole squared, and now this is e raised power of, in place of 2x we will write t, and in place of dx we will write dt by 2. So this half goes outside. Now let's simplify it and write it in a form suitable for us. So what do we get? 1 upon t by 2 can be written as 2 upon t minus, this will be equal to t upon 4. So it becomes 4 upon 2t squared whole into e raised power t dt. This 2 gets cancelled. So clearly 2 is a factor which is common to both these terms, and we can take it outside. So we get 2 times 1 upon t minus 1 upon t squared e raised power t dt. This 2 and this 2 gets cancelled, and this gets written in terms of 1 upon t minus 1 upon t squared e raised power t dt. Now this is in the standard form where if you put ft as 1 upon t, we get f dash t is equal to minus 1 upon t square. Therefore, it is in the standard form ft minus f dash t into e raised power t dt, whose integral directly can be written as e raised power t into fd. We don't write plus or constant because it's a case of definite integral, and therefore we get I is equal to e raised power of t into ft is 1 upon t, and the limits are from 2 to 4, and clearly we know that these limits are for t, and so directly we get the answer I is equal to e raised power 4 upon 4 minus e raised power 2 over 2. Or if you want, we can take out this e squared common also, and this becomes, and 4 also common, so we get e squared is left here, minus 2 is left here, and this is the answer. So with this, on the same lines, you can complete the entire exercise 7.10 and do related questions. Thank you.